let us see what the focus of a concave mirror means. So this is our concave mirror, and as we have seen last time, this is the principal axis, this is the center of curvature, this is the P pole. Now there are certain rules when it comes to incident and reflected rays in such mirrors, in spherical mirrors. So basically, when the incident ray is parallel to the principal axis, so when these two are parallel, the reflected ray always passes through the focus. And we know that the focus is a point where all the reflected rays intersect or they converge at the focus. So we have seen what the focus is. So whenever the incident ray is parallel to the principal axis, when these two are parallel, the reflected ray invariably passes through the focus. Alright? And whenever the incident ray passes through the focus, now let us denote it like this, or wait, even better, when the incident ray passes through the focus, the reflected ray is invariably parallel to the principal axis. So these are the rules. Oh god, yeah, these are the rules. The point where the rays converge is the image, and in this case the image is real. So when is an image called real? The real image is when these reflected rays actually converge. We see that these rays actually meet at this point, they actually reflect and intersect here. So that is when the image is called real. Now let us quickly consider the same for convex mirrors. Now there's this surface bulged outwards. We have this principal axis wherein this is the center, this is the focus. Now here what happens is this thing follows the same rules as the rules for concave mirrors, that whenever there's this incident ray which is parallel to the principal axis, the reflected ray passes through the focus, but instead of actually passing through it, it appears to pass through it. So what happens is, this is the incident ray and this is the reflected ray. When I extrapolate it or when I extend it, it appears to pass from the focus. Similarly, any ray which is directed towards the focus or which is likely to pass through the focus when extrapolated is going to be parallel to the principal axis. Here the image is going to be virtual because the reflected rays don't really meet. They appear to converge from the focus when you extrapolate it. When you extend it like this, they appear to come from the focus, but they don't actually converge. They don't actually, diverge from the focus or go and converge there. So these cause a deception and hence are called virtual images. Now, how to find whether images are virtual or real? So when they actually intersect, they form real images, and when they don't intersect or appear to intersect, they form virtual images. Now let us quickly consider another example. Some nice light color will do. Yes. All right. So as an example, I take this concave mirror and it has a principal axis, it has a pole, it has a focus and a center of curvature. Now let us say there's this tree, there's this tree between the focus and the pole of the mirror. So the question is, where will the image be? Where will the image of this tree be? Let this tree be AB for our convenience. So now there's this tree between the focus and the pole. Let us consider this. Here comes an incident ray parallel to the axis from the tree. Okay, fine, I get it. From the tree. Now this thing will obviously pass through the focus. So here comes our first ray. Now let us say there's another ray, color B, let the color be orange. Okay, so there's this nice orange shade we have here. Yes, and there's another line passing through it, which is, we know the angle of incidence I is equal to the angle of reflection. So there's another thing passing through it, or maybe let's okay, there's another line passing through the tree. Angle of incidence is equal to the angle of reflection. Now what we see here is the two rays, which I shall now highlight. The two rays appear to diverge. Okay, they don't really meet anywhere on this side of the mirror. No, they don't meet here. They appear to diverge. They're not going to meet on this side of the mirror. So where will they meet? Or will there be an image? Yes, there is going to be an image. But we know that images for concave mirrors are real. So this time when the object is between the pole and the focus, the image for a concave mirror is not real. For the two, as I said, never really meet, but they do appear to meet here. If you see, if I extrapolate this, and if I extrapolate this, I see there's an image here. Oh god, I lost the green. Okay, so there's this image here, which I shall call AB. Yeah, which I shall call AB, which is large, erect. Okay, so this I will call A dash B dash. So the image is virtual, meaning that the reflected rays never really meet, but they appear to converge somewhere behind the mirror. They appear to converge at this point. I'll show in black. At this point they appear to converge. So thus the image is virtual, as we can infer from the figure that it is significantly larger than the object. So it is large or enlarged and erect. Now consider another example. So we have this mirror again. The principal axis, the focus, and the center of curvature. Now let us say there is this object. This time we won't take a tree. This is a flower, a nice pink flower, between the center and the focus. So I want to know where the image will be formed. For that I must first consider an ray incident parallel from the flower, parallel to the axis. Now it will invariably go to the focus. I shall extrapolate it just in case. Now let us say there is another And then there's another ray from the flower which passes through the focus and is parallel to the axis. Now let us do some manipulation. I'm sorry, I'm not good at drawing, but when you draw this with a scale and a pencil or with the right equipment, you'll get it right. So this is the center of curvature. If you see the image which is right here, the point where the reflected rays converge. So this is the ray, this is where they converge. So if you consider this point where they converge, now let us highlight it in red. And if you extrapolate or extend this, you see this is the image. So this image, I must say, is inverted. It is not erect, meaning that the flower is going to be inverted. And magnified. So if you see this flower here, this inverted, it is real because it is formed by the real convergence of two rays. So you can similarly find out the image positions for different images at different for different positions of objects. Now let us do one for convex mirrors, and that will be it then. So this is our convex mirror. Okay, let's do it here. Focus, center, the principal axis, let us say okay, now this is the pole. This is the pole, and yes, that's it. So whenever there's this object anywhere over here, let us say no, not a tree, there's this dog who has 4 legs over here. Now let this be the incident ray, the reflected ray. If you extrapolate it, it will appear to come from the focus. Let there be another ray, let us say in some nice shade. Yeah. And then there's this ray which is directed towards the focus. Okay, undo this. And turns out to be parallel to the axis. I don't know why I can't draw this. Okay, I equals R, and now if you extrapolate this, there's going to be this apparent convergence of the two rays you will see here. Over here at I, and that is going to be the image of the dog. So now let us draw the image which is apparently smaller than the actual dog. So this is our miniature dog, but it is erect. So the image formed by a convex mirror is always erect. It is smaller or diminished, and since the rays don't actually meet